When burying a 58 kHz antenna in cement for anti-shoplifting systems, several legislative considerations related to safety and electrical codes must be taken into account, both in Canada and the United States. In Canada, the Canadian Electrical Code, or SEC, governs electrical installations. Rule 26.102 states that all electrical wiring must be installed in accordance with the CEC. This means the antenna and its associated wiring must adhere to the CEC standards. Rule 24.100 specifies that underground installations must be protected from physical damage. The antenna needs to be installed in a way that prevents damage from external forces, such as ground movement or impact. The Radiation Emitting Devices Act, or REDA, regulates the sale, import, and use of radiation-emitting devices, including antennas. Depending on the power level of the antenna, specific authorization or registration might be needed. In the United States, the National Electrical Code, or NEC, is the primary standard. Article 800 covers communication circuits. Section 800.154 states that cables and conductors used for communication circuits must be listed for the purpose. This means that the cables used for the antenna must be specifically approved and listed for communication circuit applications. Section 800.156 requires that communication cables be installed to minimize electromagnetic interference. The installation should prevent the antenna from causing interference with other electronic devices. The Federal Communications Commission, or FCC, also has regulations. Part 15 outlines regulations for unintentional radiators, including low-power devices like anti-shoplifting antennas. The antenna may require specific labeling and certification to comply with Part 15 of the FCC regulations. Some general safety requirements apply to all installations. The antenna should be buried in a location that is not subject to excessive mechanical stress or moisture. Proper placement can prevent damage and ensure longevity. The antenna cable should be properly sealed to prevent moisture ingress. Moisture can damage the antenna and compromise its performance. The installation should be performed by a qualified electrician to ensure compliance with electrical codes and safety standards. A professional electrician will be familiar with local codes and best practices. Anti-shoplifting antennas are typically classified as Class B Part 15 devices under the FCC regulations. This classification has specific implications for how the device must be installed and operated. The antenna must be installed in a manner that minimizes interference with other electronic devices and should be shielded to prevent electromagnetic radiation from escaping the detection zone. Shielding ensures that the antenna operates within regulatory limits and does not interfere with other systems. To ensure compliance and safety, it is recommended to consult with a qualified electrician or telecommunications engineer. These professionals can provide expert guidance and ensure that the installation meets all applicable codes and safety requirements. Obtain any necessary permits or registrations from local authorities, if required. Local regulations may vary, so it is important to check with local authorities to determine if any permits are needed. Follow the manufacturer's installation instructions carefully and test the system thoroughly after installation to verify proper operation and compliance with safety standards. Testing will confirm that the antenna is functioning correctly and meets all safety standards. The 2014 National Electrical Code provides detailed guidelines for electrical installations, including those involving communication circuits and underground wiring. When installing a 58 kHz antenna in cement, several articles and sections of the 2014 NEC are particularly relevant. Article 300 covers general wiring methods and materials. Section 300.5 addresses underground installations. It specifies the requirements for burying cables and conductors, including minimum burial depths and protection methods. The depth at which the antenna and its associated wiring must be buried depends on the voltage and the type of wiring method used. For example, direct burial cables typically require a minimum burial depth of 24 inches, while cables installed in conduit may have different requirements. The antenna cable must be suitable for direct burial or installed in a conduit approved for underground use. The conduit should be made of a material that is resistant to corrosion and physical damage. The backfill material used to cover the cable or conduit should be free of sharp rocks or other objects that could damage the wiring. Article 310 covers conductors for general wiring. Section 310.15 provides guidelines for determining the ampacity, or current carrying capacity, of conductors. The size of the conductors used for the antenna wiring must be adequate to carry the anticipated current load. The ampacity of the conductors must be derated if they are installed in close proximity to each other or in an environment with high ambient temperatures. Article 725 addresses Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. Anti-shoplifting systems often use power-limited circuits to reduce the risk of electrical shock. If the antenna is powered by a Class 2 or Class 3 circuit, the wiring must comply with the requirements of Article 725. These requirements include using listed cables and limiting the voltage and current of the circuit. Article 800, as mentioned earlier, covers communication circuits. Section 800.110 addresses grounding and bonding requirements for communication circuits. The antenna and its associated equipment must be properly grounded to protect against electrical shock and to minimize electromagnetic interference. The grounding conductor should be connected to a suitable grounding electrode, such as a ground rod or a metal water pipe. The bonding jumper should be used to connect all metal enclosures and equipment to the grounding system. In addition to these specific articles and sections, there are several general requirements in the 2014 NEC that apply to all electrical installations. These include the requirements for workmanship, identification of conductors, and protection against overcurrent. All electrical work must be performed in a neat and workmanlike manner. Conductors must be properly identified to prevent confusion and to ensure that the system can be safely maintained. Overcurrent protection devices such as circuit breakers or fuses must be installed to protect the wiring from overload and short circuits. When installing a 58 kHz antenna in cement, it is also important to consider the environmental conditions. The antenna and its associated wiring will be exposed to moisture, temperature changes, and other environmental factors. The materials used for the installation must be suitable for these conditions. For example, the antenna cable should be rated for direct burial and should be resistant to moisture and sunlight. The conduit should be made of a material that is resistant to corrosion and physical damage. The cement used to encase the antenna should be a type that is suitable for outdoor use and that will not crack or crumble over time. Finally, it is important to consult with local building codes and regulations. These codes may have additional requirements that are not covered by the 2014 NEC. For example, some jurisdictions may require a permit for electrical work or may have specific requirements for underground installations. By following these guidelines and consulting with qualified professionals, you can ensure that the installation of a 58 kHz antenna in cement is safe, compliant, and reliable. Additionally, considering the electromagnetic compatibility, or EMC, of the installation is crucial. EMC refers to the ability of the antenna system to operate without causing or being susceptible to electromagnetic interference. Several factors can affect the EMC of an antenna system, including the design of the antenna, the quality of the cables and connectors, and the grounding and bonding practices. To minimize electromagnetic interference, it is important to use high-quality cables and connectors and to ensure that the antenna is properly grounded and bonded. Shielding the antenna can also help to reduce electromagnetic radiation. Furthermore, the location of the antenna can affect its EMC performance. The antenna should be located away from other electronic devices that could be susceptible to interference. It should also be located away from sources of electromagnetic noise such as power lines and transformers. Testing the antenna system for EMC compliance is essential to ensure that it meets regulatory requirements and does not cause interference with other electronic devices. EMC testing can be performed by a qualified testing laboratory. In addition to the technical and regulatory requirements, it is also important to consider the aesthetic impact of the antenna installation. The antenna should be installed in a way that is visually appealing and does not detract from the appearance of the retail store. This may involve concealing the antenna or integrating it into the building's architecture. Collaborating with architects and designers can help to ensure that the antenna installation is both functional and aesthetically pleasing. Regular maintenance of the antenna system is also crucial to ensure its continued performance and safety. This includes inspecting the cables and connectors for damage, cleaning the antenna, and testing the system for proper operation. A maintenance schedule should be established and followed to prevent problems from developing. Finally, it is important to keep accurate records of the antenna installation, including the date of installation, the materials used, and the results of any testing. These records can be helpful for troubleshooting problems and for demonstrating compliance with regulatory requirements. In summary, burying a 58 kHz antenna in cement requires careful consideration of various factors, including electrical codes, safety standards, electromagnetic compatibility, and aesthetic impact. By following these guidelines and consulting with qualified professionals, you can ensure that the installation is safe, compliant, reliable, and visually appealing. When choosing a qualified electrician or telecommunications engineer, verify their credentials and experience. Ensure they have a thorough understanding of the relevant electrical codes, safety standards, and EMC requirements. Ask for references and review their previous work to assess their capabilities. A knowledgeable and experienced professional can help to navigate the complexities of the installation process and ensure that the antenna system is properly installed and maintained. Consider the long-term costs associated with the antenna installation. While it may be tempting to choose the cheapest option, this can often lead to problems down the road. Using high-quality materials and hiring qualified professionals can help to reduce the risk of failures and the need for costly repairs. Regular maintenance can also help to extend the life of the antenna system and minimize its total cost of ownership. In addition to the technical aspects, it is important to communicate effectively with all stakeholders involved in the antenna installation. This includes the retail store owner, the architect, the electrician, and the telecommunications engineer. Clear communication can help to prevent misunderstandings and ensure that everyone is working towards the same goals. Regular meetings and progress updates can also help to keep the project on track and within budget. When selecting the cement for encasing the antenna, choose a type that is specifically designed for outdoor use and that is resistant to cracking and crumbling. Consider using a concrete mix with additives that enhances durability and resistance to moisture. Proper mixing and pouring techniques are essential to ensure that the cement provides adequate protection for the antenna. Allow the cement to cure properly before putting the antenna into operation. The curing process can take several days or weeks, depending on the type of cement and the environmental conditions. During the curing process, keep the cement moist to prevent it from drying out too quickly. Consider using a sealant or coating to protect the cement from moisture and other environmental factors. This can help to extend the life of the cement and prevent it from deteriorating over time. Inspect the cement regularly for cracks or other signs of damage. Repair any damage promptly to prevent further deterioration. If the cement becomes severely damaged, it may be necessary to replace it entirely. When installing the antenna cable, use a conduit to protect it from physical damage. The conduit should be made of a material that is resistant to corrosion and physical damage. Secure the conduit properly to prevent it from shifting or moving over time. Use appropriate fittings and connectors to ensure a watertight seal between the conduit and the antenna. Avoid bending the cable excessively, as this can damage the conductors. Use a cable lubricant to reduce friction and make it easier to pull the cable through the conduit. Test the cable for continuity and installation resistance before and after installation to ensure that it is not damaged. When grounding the antenna, use a grounding electrode that is approved for the purpose. The grounding electrode should be made of a material that is resistant to corrosion. Install the grounding electrode in accordance with the requirements of the National Electrical Code. Connect the grounding conductor to the grounding electrode using a suitable connector. Ensure that the grounding conductor is properly sized to carry the anticipated fault current. Test the grounding system for proper operation to ensure that it is effective in protecting against electrical shock. When shielding the antenna, use a shielding material that is effective in blocking electromagnetic radiation. The shielding material should be properly grounded to ensure that it is effective. Consider using a shielded enclosure to contain the antenna and its associated equipment. Test the shielding system for effectiveness to ensure that it is meeting the required performance levels. When testing the antenna system for proper operation, use appropriate testing equipment and procedures. Test the antenna for signal strength, coverage area, and interference levels. Test the grounding system for proper operation. Test the shielding system for effectiveness. Document the results of all testing and keep accurate records. In addition to these specific recommendations, it is important to stay up to date on the latest electrical codes, safety standards, and EMC requirements. Attend industry conferences and training sessions to learn about new technologies and best practices. Subscribe to industry publications and online resources to stay informed about the latest developments. By staying informed and following these guidelines, you can ensure that the installation of a 58 kHz antenna in cement is safe, compliant, and reliable. The installation process should also include a detailed risk assessment. Identify potential hazards associated with the installation, such as electrical shock, falls, and exposure to hazardous materials. Develop and implement control measures to mitigate these risks. Provide workers with appropriate personal protective equipment, such as gloves, safety glasses, and hard hats. Ensure that workers are properly trained on safe work practices. Supervise the work closely to ensure that safety procedures are followed. In case of an emergency, have a plan in place to respond quickly and effectively. Include emergency contact information, evacuation procedures, and first aid instructions. Review the risk assessment regularly and update it as necessary. Final step in the installation process should be a thorough commissioning of the antenna system. This involves verifying that all components are properly installed and connected, testing the system for proper operation, and documenting the results. Commissioning should be performed by a qualified technician who is familiar with the antenna system and its requirements. The commissioning process should include the following steps: verify that all components are properly installed and connected. Test the system for proper operation, including signal strength, coverage area, and interference levels. Adjust the system settings as necessary to optimize performance. Document the results of all testing and adjustments. Provide the retail store owner with training on how to operate and maintain the antenna system. The commissioning process should be documented in detail and kept on file for future reference. After the antenna system is commissioned, it is important to perform regular maintenance to ensure that it continues to operate properly. Maintenance should include the following steps: inspect the antenna and its associated equipment for damage or wear. Clean the antenna and its associated equipment to remove dirt and debris. Test the system for proper operation, including signal strength, coverage area, and interference levels. Adjust the system settings as necessary to optimize performance. Replace any worn or damaged components. Document all maintenance activities. A maintenance schedule should be established and followed to ensure that the antenna system is properly maintained. The maintenance schedule should be based on the manufacturer's recommendations and the specific operating conditions. By following these guidelines and recommendations, you can ensure that the installation of a 58 kHz antenna in cement is safe, compliant, reliable, visually appealing, and properly maintained. This will help to protect your investment and ensure that the antenna system provides years of trouble-free operation.